for the sludge thickener and odor controls. So that will be the final topics which will happen in week 14. Okay, I would like to give a very short lecture before you start with your presentation, to have the overall, to see the overall idea, what is solar distillation as well as UV disinfection. So let me share the slide, very short one. Okay, first, these are the installation. There are methods that can be used for distillation, multiple effect, multi-stage flash, and vapor compression. These are at research level. This is do we configure the solar distillation, but the schematic diagram here are the basic unit that involved in solar steel, where is required the space for the humid air, the space for saline water, the collector, and as well as the tubular cover. Okay, and these are the next stage where the solar energy get intact with the transparent tubular cover, and it will promote the process of condensation as well as evaporation. So these are the processes that allow the separation of the salt from water. Before I go further, I forgot to mention to you that this is mainly for the treatment of seawater or salt water. Because due to the condensation process and evaporation process, it has the ability to separate salt from water. But normally when we employ this kind of methods for the treatment, we still require further disinfection process, because this process can kills. This process can remove up to 99% of salt, meaning to say that you will get pure water, fresh water from saline water. So we can. This is very in terms of cost. They are very high efficiency, but in terms of wide range of usage, not really, because it can only be used for the treatment of seawater. But good in case that we are having problem, shortage of the surface water. So this can be the best option. As compared to membrane can also remove salt, but the technology seems to be very expensive. It's require frequent maintenance. So as compared to this one, is less maintenance, but less maintenance. The cost is not so expensive because we use solar energy. Solar, and this system comprise of active and passive unit. For active unit, direct solar energy use to promote the evaporation as well as the condensation. For passive unit, direct sun solar energy was used to promote the evaporation as well as the condensation. Nevertheless, for the active unit, normally the solar energy which has been extracted will be stored in a battery, in a cell, so that it can be used for higher efficiency, or later for the treatment during night. So that's why we have two types, for the active as well as the passive. Passive is a direct solar energy, while active we have a cell so that we can store the energy. Okay. So at the bottom part of the system, we have distilled water, which is the production. This the fresh water where we have removed the salt content. Okay. So the two major processes involved, which is condensation and evaporation. Okay, already mentioned. So this is mainly for the treatment of seawater. there are two major disadvantages. Is a large energy input is required, even though we use solar energy, but it's required large energy input to promote the condensation as well as evaporation. So the concept is like when how the rain being developed, so when the condensation and evaporation process occurs, so that the water vapor will form in the cloud, at certain weight, it will drop as rain. So the same concept being applied for solar distillation. So in case we know that it's require uh, large energy input. However, since the energy inputs is from renewable energy, which is solar, so at this moment they have been trying to work on the active unit, where they try to collect, to store as much as energy they can. Okay. If simple distillation is used, then chemical contaminants with boiling point at certain condition, these system are mainly being designed to remove salt. If you are talking about other chemical contaminants, especially the one below boiling point, so that is very difficult for us to use as the treatment. Because this system has been proven to be very good only for the removal of salt. If we are talking about salt, meaning to say that good for the removal of sodium, good for the removal of magnesium, good for the removal of potassium, good for the removal of calcium. So these are four major salt family. The first one definitely sodium, the major ingredient for the seawater. Okay, so this is actually the one that at the bottom of the slide. This is the unit that available in our lab. It's actually available in hydraulics lab. Many years ago, we do have one lecturer who has been working on this, but he already left to Bangladesh. He's a Bangladeshi. So we do publish a few journals on solar distillation, and we do produce about 3 to 4 PhD students on this system. So we have been working more on improving the active solar system, so that we can store more energy. So we tried to use many types of various type of material to improve the energy storage. But the efficiency of the system is still the same, but the one that we have been focusing on to improve the energy storage. Because every time we try to run the system, if we have sufficient energy, we can remove up to 99% of the salt content. This is a very promising system, to remove salt content. But we have to find a way to improve the energy collection, the energy storage. So in this case, I think the student use plastic bottles and PVC types, a PVC pipe, to improve as the energy storage, for the solar system after it's being exposed. The solar panel being exposed to the being exposed by from the sun, so that it can collect more energy. Okay, so this is basin type solar steel. So can so basically solar steel can desalinate impure water, give some specific advantage compared to conventional distillation, a low output yield, and works similarly like the process of rain. So what is conventional distillation? Conventional distillation is the one that we use in our lab. We use the heating. We use temperature, to allow to separate water and the salt. But in this case, we use the solar energy, right? So the next one is UV disinfection. Before we go for UV disinfection, maybe we can spend a few minutes on this video. The this one, okay.
These are two solar distillation units. They are very low-tech but very effective ways of taking undesirable water. It's dirty, it's too salty, it's got bacteria, it's got minerals you don't want. You can take that undesirable water, place it inside the still, and through the process of being heated by the sun, evaporating, and then condensing on the surface of the glass, or in this case, plexiglass and then glass there, and drips down into a trough and flows into the jar. It's kind of like what happens with rainwater. The sun heats the ocean, heats a lake, heats a river, the water evaporates up, it condenses into clouds, and when the clouds get to a certain size, it rains. And that's the same thing here. You can see it where the water's evaporating up, the little water droplets are kind of like the clouds, and when you get a water droplet of a certain size, it will drip down and start the whole process going. We decided to do some research on these because of the needs of some communities in southern New Mexico, in Mexico, internationally, where they have water perhaps, but it's impure for whatever reason. Again, dirty, bacteria, salty, and we wanted to make these such that they could be constructed in just about any place. Both of these are made out of simple materials. That one's made out of an old toolbox. This is made out of polycarbonate, which is available in every continent on the planet. And this one's got a polycarbonate front, which is unbreakable. That has a glass front, which is a little more efficient, but you could break it. The idea is they could take this, and if they're in a situation where they have water, whether it's at their home or if it's in a disaster situation, like in Haiti or in New Orleans or in Pakistan, where people were dying of thirst, even though there was water everywhere. Of course, they couldn't drink the water because it was undesirable. But with a small unit like this, somebody in a disaster situation could provide enough drinking water to serve their needs. We've figured that for a family of 4, each person consumes about 1 gallon a day in drinking and cooking water, that for a family of 4, 2 square meters would be about enough. 20 square feet in the American units. And so something 6 by 3, 7 by 3, you could provide enough water for a family of 4. Of course, in the summer with greater solar energy, you get a little more water. But again, with that 2 square meters, you could make about 4 gallons a day, which would be enough for the family of 4. Here in New Mexico, down in Columbus, they have groundwater, not too deep, but the groundwater has lots of uranium and lots of fluoride in it. A family could put this, take the water that comes out of the tap, you could shower with it and wash with it, but for drinking, you'd take 4 gallons, put it into the solar still, and create pure water that you could easily drink. It comes out about 99.9% pure. So you can basically take as junky a water as you can get and make incredibly pure water out the other end.
All right. Okay, so this is a very good video, I believe, which has given us
The preceding was a production of New Mexico.
a good explanation on about solar distillation. All right, so next one is on UV disinfection. Okay, these are the diagram from one of our water treatment plant, where they use UV water disinfection light instead of the chlorine. You can see I have marked here as 1, 2, 3, 4. Okay, 1 is from the filtration. Number 2 is the sediment filter. Number 1 and 2 is from the filtration system. Number 3 is the sediment filter. Number 4 is the charcoal filter. So this is again further improvement by through application of the activated carbon, which is charcoal here. And after that, number 4, number 5 to the softener. Number 6 from softener to the house. So before number 5 to the softener. Number 6 it will go through the UV water disinfection line. So this is the replacement instead of using the chlorination to kill the germs, to kill the microbes which can cause disease. They use the UV water disinfection, and after that it can be released to the consumer. Okay, the concept of UV lamp, the UV lamp comprised of four main chambers, which is reactor chambers, UV lamp, the quartz sleeve, and the ballast controller unit. Yeah. So the way the system works is when the UV radiation get intact to the microorganism, it will alter the DNA of microbes, so that it can prevent them from further growth and reproduction. That is the function of the UV light, at certain wavelength. It will alter the DNA of the microorganism, thus prevent them from for further growth as well as reproduction. So these are being used in Singapore and in water center. They use UV lamp as the final unit, before the water, the treated wastewater, can go through for the industrial usage as well as for further treatment for water as a surface water. Okay, all right. So let's watch one video here. This one, I think this one very short one, 3 minutes video.
Welcome to a quick primer on autonomous disinfection solutions presented by the Mobile Robot Guide. This short presentation will introduce you to the UV light disinfection process. All of this information, including recommendations, is included in the 2020 Mobile Robot Buyer's Guide. If you have responsibility for reopening your business or managing a facility, then you are concerned about the safety of your frontline workers. You're also concerned about disinfecting your workplace and controlling the spread of microbes and viruses. So let's learn how UV light disinfection works. Microbes and viruses are always present on exposed surfaces. A UV light source is lethal to microbes. With appropriate intensity and exposure time, the UV light destroying their DNA. However, to be effective, the light must be on the surface long enough for the light photons to do their job. And light follows what is known as the inverse square rule, which simply means that a surface that is twice as far from the light source requires 4 times the exposure to have the same effect. A surface 3 times further away requires 9 times the exposure. So here are a couple of things to consider when evaluating a UV disinfection solution. First of all, it should be lab tested, and those results of the testing must be available to you as a purchaser. Second, the UV lights should be calibrated by the manufacturer, and they should come from a reputable source. Third, the system must protect human operators and the public from accidental overexposure, because UV light is hazardous to human cells as well. And last, the best solutions on the market must actually calculate the proper exposure for each given situation. Now, all of this information we've talked about and more is included in the 2020 Buyer's Guide, including reviews for 20 autonomous mobile robot UV light disinfection.
All right, okay. Yeah, that is very short explanation about the UV, the application of UV light. But I believe that all of you should have a better explanation regarding on how the system being applied for the treatment for the treatment of treated water, for tertiary treatment of treated water. Okay, maybe we can start the very short presentation from our first group. Yeah, the first group. May I know who actually led the first group?
Muhammad Hakim.
Okay, Muhammad Hakim. This is not compulsory because everyone do have your own slide, kan? So everyone can present your own slide, but it's better to compile, to compile as a group work, but I will evaluate individually because you do have your name provided on each slide. Okay, so we can start with group number 1. You can start sharing your slide now.
Amiro, can you
So
share
it's
the
not
slide?
necessary. You share the slide.
Assalamualaikum doktor.
Okay, salam.
Nak start dengan presentation doktor?
Yes, correct.
Kita
How
orang
many
start dulu
slides?
doktor. Doktor nampak slide
Okay,
kita orang?
boleh. Yes, topic number 2, right, Ashraf?
Ya doktor. Solar
Okay,
distillation.
you can start with the presentation. Thank you, Ashraf.
Assalamualaikum warahmatullahi wabarakatuh and very good evening to Dr. and everyone. Today we are from the group 4 which will cover the topic 2 of the solar distillation. Okay, first my name is Muhammad Iqwan bin Zaidi. Okay, for the first part is the solar distillation in the seawater desalination system part 1. Okay, the solar distillation is a method of separating the seawater from the ocean into the freshwater salt and remove the contaminants from the original resources by the help of the energy obtained from the solar system. The seawater come from the intake were pumped to the black container from the picture, which will be heated by the sun, and the seawater will be converted into the water vapor. When the water vapor rise to the top, it will start at the glass and drips down to the what you call
The trough.
to the
To the
drain,
what?
and then the water will be collected in the collection container. The water inside the collection container will be fresh water, and the substance left in the black at middle is a salt. That's from me. Next.
Okay, so for solar distillation part 2. So for
Israf,
distillation.
So Israf tu.
Yes doktor.
Just now Hakim part 1.
Ikhwan.
Sorry.
Yes.
Ikhwan doktor, Ikhwan.
Part 1. Okay, thank you.
So for part 2, desalination purpose, the amount of dissolved gases in seawater, especially oxygen and carbon dioxide, as they are released during heating, corroding and metallic surface is very important. So for the corrosion, scale formations and fallings are important also factors for the proper operation of desalination systems. Basically, the corrosions deteriorates all metallic part of distillation plants of the process, and scale formation decrease the heat transfer coefficients, and as a consequence the fresh water productivity. Okay, so the last desalination systems use a raw material, seawater, and brackish water discharging simultaneously back to the sea. And then seawater salt concentration is affected by various parameters such as from the region, the geographic location, the seasons of the year, and from local condition as a local current. So for each intake site, salinity and other fluctuating parameters that affect appropriate operations of the desalination systems must be examined very carefully as fluctuations of salinity. Basically, the density and temperature are of the importance for the smooth and efficient operation of any desalination systems. That's all from me. Pass to my friend.
Okay, thank you. Next presenter.
Now we move to the factor affecting performance design parameters. Okay, first is evaporation surface area. The evaporation process will be increased when the surface area are increased. The molecule will move and vibrate more quickly in a large surface area compared to small surface area due to large surface that exposed to sunlight. The picture shows how the differences between a large surface area and small surface area. The large surface area has more molecule vibrate compared to small surface area. So next is storage material. The material used for the storage tank should be able to absorb heat from sunlight. The performance of the system will depend on the effectiveness of the storage tank to absorb amount of heat from sunlight. If the material that we use for the storage is a high effectiveness to